Okay, sorry about that. As you could see, the board just didn't respond. So one day when you guys are millionaires, no? Which will be some of us, not us, of you. You must teach us, no? Teachers don't become millionaires. So, then you guys can must buy me Apple computer and I'm joking. Okay. So, what I was trying to show you at this point, where the computer cut us out, it saved nothing of the work we've done. Okay, but just going back to that pattern we had. Remember? It seemed to be only 17 weeks that person can save for the car. It doesn't make almost sense. Not so. But if you look at the pattern and actually what happens, this is on exercise, what is this? 9, page 23. The pattern was 1, 2, 3, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, 8192, 16,384. Yes? 32,768. Can you see what happens? This exponential growth in this. If you work out, instead of doing all of this, I could have just said what's happening at T17. What would have been the last payment he would have made? Would have been 1 into 2, 17 minus 1. Work that out. $65,536. Can you see that? Could you have saved that on the Saturday job? Of course not. But does it make sense that you could have, on this method, you could have saved it in 17 weeks? Okay. Initially, it might look small, but the growth is exponential. Okay. It's phenomenal. Okay. Okay, so let's open the textbook again. Alright, so for homework, I want you guys to do number 5, exercise 9, number 5, and number 6. Do 5, 6, and 7. Yeah. So today we're looking at quadratic patterns and combination of arithmetic and geometric sequences. This is on page 25. So on page 25 we are reminded about all the formula that we are familiar with. We have the arithmetic formula, we have the geometric formula, and what we done last year was the quadratic formula for the number of terms, not so the general term. So now we're going to look at the combination thereof. Okay, page 25. Alright, so worked example 1 on page 25, we are told, consider the quadratic sequence. Negative 6, 2 minus x, 4, and 2x plus 5. So, if you're looking at the quadratic pattern, what is exclusive to a quadratic pattern? That only a quadratic has. It has a second common difference. Not so. So let's just take you one step back. And let's just look at the quadratic pattern quickly. Alright? We just generate a pattern quickly. And I'm going to remind you how the quadratic patterns work. Okay. So we're going to start with minus 5, minus 15, minus 29, minus 47, and minus 16. Okay. So, what do we do for the quadratic pattern? Or any number pattern? We try and either find a constant difference or a constant ratio. Not so? You always try and find one of those. So here, how do you move from one term to the next? We subtracting 10 and then subtracting 14 and then negative 47 minus 29. It's negative 18. Check. Then should be negative 22. Is that correct? Yes. So is this arithmetic? No. Why not? Does not have a constant first difference. However, we take it one step further. How do we move from one to the next? Minus 4. Then minus 4. Then so what do we write on the side? 2a, yes? 2a, 3a plus b, a plus b plus c. We go from the bottom. You all agree with that? Okay. So we have Tn is equal to an squared plus bn plus c. This is the standard form of a quadratic pattern. Okay? So what do we say here? 2a is equal to negative 4. So divide by 2 both sides. So a is equal to negative. Okay? Any confusion here? So what do we do now? We substitute this a in the second one. You guys see that? So what do we have now? 3 times negative 2 plus b is equal to negative 10. Okay? So that's going to give us negative 6. So b is going to be negative 10 plus 6, which is negative 4. That's how we get b. Okay? So what do we do now? We got a, we got b, we just need to calculate c. That's all. So what do we have now? Negative 2 plus negative 4 plus c is equal to negative 4. So that is going to be negative 2 minus 4 is negative 6. So c is equal to negative 5 plus 6. And there was negative 5 plus 6. Okay. So this here is simply Tn is equal to negative 2n squared minus 4n. Now this sum is normally worth a minimum of 4 marks. Sometimes they give you 5 or something. So it's worth testing if it's correct. Not so? We never test for term 1, let's go rather with term 3 or 4. So wherever we see a n, we put a 3. Let's get, so we're testing for term 3. So we got negative 2 open brackets, 3 squared minus 4 times 3 plus 1. Now this is for term 3. So if you count 1, 2, so the answer should be negative 29. If it is negative 29, we are correct. If it's not negative 29, it is then incorrect. Not so. You must have try and check where we went wrong. So yes, negative 29 is absolutely correct. You guys understand? Okay. You want more on quadratic patterns, you can let me know. This is also coming from the grade 11 textbook. It's a nice exercise on quadratic patterns. Very important to understand because the question comes in often. Okay? I need the space, so I need to take this off. Okay. So, the work example 1, it says consider the quadratic sequence. Okay. So we got negative 6, 2 minus x, we got 4 and 2x plus 1. We got 4 terms here. Okay. You all understand? So for a quadratic pattern, as we did before, we're moving from there to there. Not so. In other words, it's going to be term 2 minus term 1. Now that we can't just do, I'm sure most of you can do it in your head, but for me to be safe, I'm going to say 2 minus x minus minus 6. Not so. So which is simply 2 minus x plus 6, which is 8 minus 6. You all okay with that? Okay, so we got 8 minus x here. Let's look at the next one. So in this case, it's going to be 4 minus 2 minus x. You all agree with that? No, not right. What's the mistake there? The brackets is more than one term following a negative sign must be a bracket. And that's a common made mistake by learners. Common made error. Okay, so don't you be caught out there. So it's going to be 4 minus 2 plus x. It's going to be x plus 2. Okay. The next one. It's going to be 2x plus 5 minus 4. Sure, you can do that in your head. It's really simple. 2x plus 5 minus 4. It's going to be 2x plus 1. So is this the first difference or the second difference? It's the first difference. But what did they tell us? It is quadratic. What is exclusive to quadratic patterns? Second common difference. The previous sums, second common difference was what? Negative 4. That's the example I used. That common difference was negative 4. Okay? The first difference is given, so I need to go one step further. So I need to know how do I get from there to there. So in other words, it's going to be x plus 2 minus 8 minus 6. So let's multiply this in. X plus 2 minus 8 plus x, which is 2x minus 6. There we go, 2x minus 6. How do we move from there to there? Again, it's going to be 2x plus 1 minus x plus 2. multiply this in, I get 2x plus 1 minus x minus 2, which is x minus 1. And this is the second difference, not so? And what did we say about the second difference and quadratic? They are equal. It has a second common difference. Does it make sense? If they had to say it's a linear pattern or an arithmetic pattern, I would have said that is equal to that. Or that is equal to that. You understand? Or the first one equal to the third. If it was linear or arithmetic. Okay? Because they say it's a quadratic, it has a second common difference. Okay? So I can say therefore 2x minus 6 is equal to x minus 1. X is one side, numbers are the other side. So it becomes 2x minus x is equal to negative 1 plus 6, which is 5. X is then equal to. Okay. So now the next question says determine the nth term in the sequence. So to determine the nth term, what do I need? I need to know the values of the terms here, the first, second, third and fourth term. Not so? How am I going to calculate that values? You substitute the 5 back in. Not so? So substitute the 5 back in. You generate a sequence and you take it from it. Okay, so what is the pattern going to be now? So wherever I see an x capital, 5. So it's going to be negative 6, 2 minus 5, 4, 2 times 5 plus 5. So it's going to be negative 6, negative 3, 4, 50. Did you all get that? Who's confused? Nobody. Okay. So how do I move from one term to the next? Sorry? You're adding 3. And then 7. And then 11. Not so? Right. So you determine the next term and the next difference. Okay. We need to move a bit because the battery is running soon. I would like to do the next example as well. Okay. So what is your next difference here? 4 and? What do we write on the side? 2a, 3a plus b, a plus b plus, from the bottom up. Not so. The general term will be in the form of Tn is equal to an squared plus bn plus c. So we firstly say that 2a is equal to 4. A is then equal to? We now substitute 2 into a. So it now reads 3 times 2 plus b is equal to 3. B is equal to 3 minus 6 is negative 3. There's your b value. So if you put negative 3 there, I can put 2 in there. So you got a and b. You all agree with that? So now we say 2 plus negative 3 plus b equals negative 6. So that is negative 1. So b is equal to negative 1. So what's my formula? Tn is equal to 2n squared minus 3n minus 5. So what did we say? It's worth testing, not so? So let's test for term 4. The answer should be 15. So you say 2 open brackets 4 squared minus 3 times 4 minus 5. And the answer is 15, which makes my pattern, my formula, correct. Okay. Any confusion? You all understand, eh? Then the question says, so I don't need to take this off.
Good morning, may I have your attention please? Rosshaus will meet at the prefab now during break. Rosshaus will meet at the prefab during break. Private meeting in room 17 now at break. Private meeting in room 17 now at break. And everyone is looking very impressive today. See you in the hall during break to get your photo taken at the photo booth.
Okay. So basically what we have is which term has a value of 400 in the sequence. We set Tn equal to 400. Okay. So it's simply going to be 0 is equal to 2n squared minus 3. And minus 5 minus 400 is minus 405. So at this point we can use the quadratic formula, not so. The quadratic formula, which is x is equal to minus b plus minus the square root of b squared minus 4ac over 2a. Okay. Well, let's use this function on the calculator. Gives me 15. So n is equal to 15, or n is equal to negative 27 over 2. But remember, n can't be negative. Not so. And n can't be a fraction either. Therefore, that one's not going to work. Therefore, T15 is equal to 400. Which means to say, if I extend that pattern by 15 terms, the 15th term would be equal to 400. Okay. Okay, so at this point, I can't give you much homework on that. Okay, so your topic for Monday, we're going to start a new chapter on Monday. We're just going to wrap this up. Will be Euclidean Geometry. Okay, so we started geometry on Monday. So, okay. So, I would like you guys to do the following exercise for Monday. We're going to do Euclidean Geometry from the Mind Action series. Now, the school has given you that textbook, not so? Right. Now, from the Mind Action series, my page number might be different to yours. Okay, so this is basically what the book looks like. Euclidean Geometry in this book is on page 233. It is chapter 8. Chapter 8 on page 233. So if it's not on page 233 in your textbook, please check where's chapter 8, okay? Some of you have a workbook as well. So it might be a different page number. It revises all the circle geometry rules, okay, which is very important for this chapter to us. Okay. What I want you guys to do is the revision exercise on page 242. As I said, the textbook might be different. Okay. It's the revision exercise on circle geometry, just to get your brain thinking in terms of geometry for next week. Okay. We will do whatever problems you have on that exercise on Monday. Okay. People enjoy the rest of your day and the weekend. Don't forget about the class this afternoon. There's no class next week. So this Friday, but next week Friday there's no class because of the event that's happening with the grade 8s. Okay, see you guys later. Enjoy the rest of your day.